Hey, welcome to Klein's Calculus. We're going to look at lesson 7-2, areas in a plane. What you're going to learn about today in this video is examples 1 through 2, and part B will be examples 3 and 4. What you're going to learn about is the area between curves on a coordinate plane, the area enclosed by intersecting curves, and we're going to look at boundaries with changing functions. We'll be integrating with respect to y and saving time with geometric formulas on Monday. Okay? This is going to allow us to compute areas of complex regions on the plane and give us a good basis for understanding when we're looking at volume in lesson 7.3. Now, here's the first part we want to talk about, definition. We're going to work off the entire section. If f and g are continuous, with f of x greater than or equal to g of x, so that means you have a function, f of x, and you have another function, g of x. And over this particular interval, let's say from a to b, you can see that f, the y values in f are above the y values in g. So to find this area, that's going to be our integral f of x minus this integral g of x. Okay? Now, don't worry if some of this area is below the curve, because if you think about this minus that negative area, it's going to add the area. So always, this formula, integrating from a to b, the upper function minus the lower function, will always give you this area. Okay? So write that down. That's what we're going to be using today. Let's look at an example of this. We want to find the area of the region between y equals the secant squared of x and y equals the sine of x. And we're going to look between x equals 0 and x equals pi over 4. Okay? Now, the first thing we need to do if we're going to use the formula is figure out which function is above the other one on that interval. Two ways to do it. If you have a calculator, just graph them and look. If you don't, plug in a value on the interval between 0 and pi over 4, maybe pi over 6. If you put in the secant squared of pi over 6, well, I always use my little right triangle thing and think, this is pi over 3, this is pi over 6, so this is 1, 2, square root of 3. Secant's the reciprocal of the cosine, so I would be looking at the hypotenuse over the adjacent. I get 2 here. And here the sine of pi over 6, square root of 3 over 2, that's a little less, so I know secant squared was higher. So that's one way you can do it, just plug them in and see. The other way, let me show you the graph. The graph is up here. If you graph it from 0 to pi over 4, you're going to see this for y equals secant squared, and this for y equals the sine of x. And this is pi over 4, 2, and this is pi over 4, 1. So you know secant squared is higher. Okay, I'm a little off on my pi over 6, but okay, that's square root of 3 over 2, excuse me. Or 2 over square root of 3, so it's a little less. So now let's look at this, though. How would you put that in your calculator if that wasn't something you've done in a while? Keep in mind secant squared, because it is reciprocal of the cosine. You can write 1 divided by the cosine of x, and then just square that. Let's get one more parenthesis in here. So I've got this and then that. And then you can do the sine of x. And then if I just looked at it, make sure you set your window over the window they're asking for, just to make your life a little easier, so you know what you're seeing. 0 pi over 4 by 1s, and 0 to 2 I went here. And if you do, you'll see, here's your graph. This is my secant squared. Here's my sine. And if I want to know, if I wasn't sure which one was which, I'd go to calculate a value and say, just put in pi over 6, put in some value in between there. And here my cursor is on this function, and I see up here, you can see that it's going to secant squared. And then if I bring it down, now my cursor's here and I see that's the sine of x. So I know secant squared is higher. So to write my integral, I'm just going to write the secant squared of x minus the sine of x, following my definition, and I'm going from 0 to pi over 4. Now, easy to calculate in your calculator, but I want to know that you can use the fundamental theorem of calculus. So your homework, you're going to be using this fundamental theorem of calculus, which means now we take the antiderivative. Antiderivative of the secant squared is the tangent. And antiderivative, I've got minus, and the antiderivative of the sine is the negative cosine of x. And I need to go from 0 to pi over 4. Well, minus and negative is plus. And I can evaluate this quite easily now by saying use the pi over 4 first, the tangent of pi over 4 plus the cosine of pi over 4, minus, and now I'm going to use the 0, the tangent of 0 plus the cosine of 0. And I hope that's going to come back. Very nice. Keeping going with this, tangent of pi over 4 is 1. Cosine of pi over 4 is square root of 2 over 2. Which occasionally your textbook authors aren't always going to rationalize the denominator. You might see that as 1 over square root of 2. Not to worry if you do, same thing. Tangent of 0 is 0, and the cosine of 0 is 1. So here I have 1 plus square root of 2 over 2. 0 plus 1 is 1 minus 1. Those will cancel out, and I'm left with square root of 2 over 2 for that area. Okay? Now, if I want to verify that that's correct, and I certainly would, that's your last step, we're going to go over, take your screen, go to math, go down to FNINT, and just put in right here, secant squared of x minus sine of x. You're going to have to go with, for your secant, parentheses 1 divided by the cosine of x, close that parenthesis, close the parenthesis that says it's a secant, square it, minus the sine of x, with respect to x, from 0 to pi over 4. You'll get an irrational number. You want to know that that's the same as square root of 2 over 2, so I'm also going to just verify square root of 2 divided by 2, and I see I get the same thing. So I know we did it right, and that answer is exact. This is a rounded one. This is the one I'm going to be looking for on your homework, okay? So these are the steps. Graph it to find the position on the plane, or just pick a point, evaluate it to see which is higher. Write your integral, your limits of integration, high your function first, evaluate it, take the antiderivative of each piece from one end to the other, and work it through to your answer, okay? So let's try another one. Let's try one with the parabola y equals 2 minus x squared and the line y equals negative x. So I'm going to come over here and I'm thinking probably negative 5 to 5. Give it a check there to see just to see where that is. Okay, and I see I can zoom in more, so since I'm going by ones, I know this is like at 1, so I'll go negative 2 to 3 here, and 2 to 3 in y. So here I've got negative 2 to 3 in the x direction, and negative 2 to 3 in the y. Will that give it to me? And there we go. So now we can see that is the function we're after. We know this is the parabola, so this is y equals 2 minus x squared, and this is y equals negative x. So this is definitely going to be higher. I need these points of intersection. We can find them analytically. We can just set this equal to this. We can write 2 minus x squared equals negative x. And the intersection is going to be where the intersection of that graph is. I like my x squared terms positive, so I'm going to add x squared, take away 2, and just solve this. So I'll factor it, x and x, and I need two numbers whose product is -2 with a sum of -1, so it's going to be -2 and a +1. So x equals 2 and x equals -1. There's my limits of integration. So I'll write that there, -1 to 2. And I can see when I come over here, totally verified on the graph, and I'm going to put then 2 minus x squared first. So this function minus my -x. And I think the first thing I'll do is simplify it. So I have from -1 to 2, 2 minus x squared plus x dx. Okay? So, you know, get rid of minus a negative, get rid of your parentheses, simplify it before you anti-differentiate. So now I need my antiderivatives, and I know 2, I've got 2x minus x squared, and I'm going to add 1 to the exponent, so I'll divide by that 3, x to the first power, add 1 to the exponent, divide by 2, and I need to go from -1 to 2. So, easy enough, keep going with your fundamental theorem. We're going to come up here, so I'm going to plug in the 2 first. 2 times 2 minus 2 cubed over 3 plus 2 squared over 2. And all of this minus, now I'm going to plug in the -1, 2 times -1 plus, minus -1 cubed over 3 plus -1 squared over 2. And then we just work it out. 2 times 2 is 4, 8/3, 4/2, which is going to be 2, -2. This is -1, so it's going to be plus 1/3 plus 1/2, because you know anytime you have a negative times a negative, it's a positive. So 4 and 2 is 6, minus 8/3, minus, I've got, I just might as well make 6 here. So I'm going to have -12/6 plus 2/6 plus 3/6. And here, I might as well make 6 all the way across. So I've got 36/6 minus 16/6. -12 plus 5, -7. 36 minus 16, so I've got 26 minus -7/6. 27/6. I'm going to check my answer. I don't remember that. I might have made a mistake. So now let's go back over here. And we're going to put in our integral. Math. And I'm going to go 2 minus x squared plus x with respect to x from -1 to 2. 4.5. And then I go, shoot, where did I make a mistake? 4, 8/3, 4. Minus -2, minus a negative, plus 1/3, plus 1/2. Good so far. 4 plus 2 is 6, minus 8/3, minus negative. So, you know, I'm going to just start right from here and I'm going to figure out what I did. Sometimes another tack would be to just distribute this. So 4 and 2 is 6 minus 8/3, and I just change all my signs. So I've got plus 2 minus 1/3 minus 1/2. 6 and 2 is 8 Now I'm gonna make all of this 6 minus 16 6 minus 2 6 minus 3 6. So I've got 8 minus 16, 18, 21, 6 equals 8 minus 6 goes into 21, 3 and a half equals 4 and a half. So sometimes just take a different tact if it doesn't work. And notice I didn't try to find the mistake in there, I just got rid of all those fractions and went about it a different way. So that's another option if you run out. So that's this process though every time. Find out which is higher, write your integral. If you need to find the intersection, solve the system or calc intersect, evaluate using the fundamental theorem. Algebra will get a little dicey sometimes, so check your answer using FNINT and go back and find the mistake if you made one. See you in class.